Hi everyone, in this video we are going to discuss about how to calculate the area of a triangle using the coordinates of its vertices. Here in the diagram we have a triangle ABC and the coordinates of its three vertices have been provided. Let's assume that the coordinates of A are x sub 1 and y sub 1, and also let's assume the coordinates of its second vertex, which is B, its coordinates are x sub 2 comma y sub 2, and similarly let's assume that the coordinates of the vertex C are x sub 3 comma y sub 3. So using the coordinates of its vertices we have to come up with some sort of a formula to calculate the area of this triangle. Now how are you going to do it? Well, to be able to do that we have to use the formula for area of a trapezium, and from there we will construct the area of this triangle. So in order to do that, first what I am going to do, I am going to drop three perpendiculars from the three vertices onto the x-axis. So let me first draw it and then we will see how that works out. Here I have drawn the perpendiculars from the three vertices and they landed on the x-axis at three different points, point D, E and F. So now if you look at this diagram here, you will notice that there are actually three trapeziums and one triangle. Now let's first think about the trapezium ADEC, and then there is another trapezium which is CEFB, and then also there is another trapezium which is ADFB. Now if you think about it, if I take the area of the first two trapeziums which are ADEC, and then if we add the area of CEFB with that, and then from there if we subtract the area of ADFB, the remaining area would be the area of our triangle ABC. Take a look at it carefully and think about it. So the sum of the areas of two trapeziums ADEC plus CEFB, and from that sum if we remove the area of the trapezium ADFB, then that is going to give us the area of our triangle ABC. So we can say that area of triangle ABC, that is equal to this quantity, sum of the areas of the two trapeziums and then minus the area of the one trapezium. Now why are we using the area of trapezium? Because it's easy to calculate since we are working on a rectangular coordinate system, right? So from here let's see what is the area of ADEC trapezium. That would be half of the sum of the two parallel sides. So that would be half times sum of the two parallel sides would be y sub 1 plus y sub 3, because the one side is AD, that is y sub 1, and then EC would be y sub 3. So sum of those two parallel sides, so that would be y sub 1 plus y sub 3 times the distance between them. Well, the distance is actually DE, and DE would be x sub 3 minus x sub 1. So that is the area of the first trapezium which is ADEC. And then with that we are also going to add the area of the second trapezium which is the CEFB. So let's see what is the area of the trapezium. Well, there again it would be half times sum of the two parallel sides which are actually y sub 3 plus y sub 2 times the distance between the two parallel sides, that would be EF, and EF is actually x sub 2 minus x sub 3. Alright, so far we have calculated the area of the first two trapeziums, and now from this sum let's subtract the area of the trapezium ADFB, and the area of ADFB would be like this. So that will be minus, we are going to now note down the area of the trapezium ADFB. So that would be again half of sum of the two parallel sides. There again the two parallel sides are AD and FB. AD is actually y sub 1 plus FB would be y sub 2 times the distance between them. Well, the distance is actually DF, and that would be x sub 2 minus x sub 1. And now let's simplify this and see what we get. So from here I'm just going to write it from the left hand side here. So I'm going to take half as a common factor, and now within a third bracket I'm now going to remove the parenthesis and do the multiplications there and see what we get. So first one would be x sub 3 times y sub 1 minus x sub 1 times y sub 1 plus x sub 3 times y sub 3 and minus x sub 1 times y sub 3. So that is for the first trapezium. And then for the second one, what we get? Well, if we now multiply y sub 3 with x sub 2, so that would be plus x sub 2 times y sub 3 and then minus x sub 3 times y sub 3 and then plus x sub 2 times y sub 2 and minus x sub 3 times y sub 2. So far we have taken care of the two areas, and now we have to subtract the area of the other one. So there we are going to begin with a negative sign, and that would be x sub 2 times y sub 1, and then negative and negative, that will be positive x sub 1 times y sub 1, and then again negative y sub 2 and x sub 2, so that would be x sub 2 times y sub 2, and then again negative and negative positive would be x sub 1 times y sub 2. And from here let's see if there are some positive and negative terms which can cancel each other. So x sub 1 y sub 1 looks like they're going to cancel each other. We have x sub 1 negative here and positive here, so they're going to cancel each other. And similarly we have x sub 2 and y sub 2, positive and negative, they're also going to cancel out each other. And also we have x sub 3 and y sub 3, so we have a positive x sub 3 and y sub 3 here and a negative x sub 3 and y sub 3 there, so they're going to cancel out each other. So now we are going to be left with 1, 2, 3, 4, 5 and 6 terms here, right? So let's make a note of those 6 terms now. So you can say half times, let's reorganize the remaining ones like this. First I'm going to write down x sub 1 and y sub 2, and then I'm going to note down this other one which is negative x sub 1 times y sub 3, and then I'm going to note down the positive x sub 2 times y sub 3, and then I'm going to note down the negative x sub 2 and y sub 1, and then I'm going to note down the positive x sub 3 and y sub 1, and then the remaining one which is negative x sub 3 times y sub 2. And now if you look at them carefully, we have 3 nice pairs here. So let's say this is half times. Now from the first pair right here, what is the common factor? Well, the common factor is x sub 1. So you're going to write it like this, x sub 1 times y sub 2 minus y sub 3. And then let's focus on the next pair, which is this pair right here, and there we have a common factor of x sub 2. So we can write it as x sub 2 times y sub 3 minus y sub 1. And then we have the third pair, which is this pair right here at the end, and there again our common factor is x sub 3, and that will give us y sub 1 minus y sub 2, and that is the formula for the area of the triangle. So let me highlight this. And if it looks pretty big and intimidating, no need to worry, I'm going to show you how to easily remember this. We can remember it like this. It is actually half times, we have to remember that much at least. Then we're going to write it as x, and then within parenthesis let's say y minus y, and then plus again let's say x times y minus y, and then plus again x times y minus y. Now let's use the subscripts. So first one begins with 1, then 2, then 3. Second one begins with a 2, then a 3, then a 1. And the third one begins with a 3, then a 1 and a 2. So it's very easy to remember like that. You start with 1, 2, 3, then 2, 3, 1, and then 3, 1, 2. And that gives us the area of the triangle ABC. So this is actually area of ABC. I hope everything made sense so far. Let's take a quick example. Suppose we have been provided the coordinates of the 3 vertices like this. And in this example, I'm going to use some negative coordinates also. Let's say we have the coordinates of the vertex A provided as negative 2, 3, and the coordinates of the vertex B have been provided as, let's say, 3, 5, and then the coordinates of the vertex C suppose have been provided as, let's say, 3, negative 2. Now we have to calculate the area of this triangle. So let's do that. So the area would be half times x sub 1. Now what is x sub 1? Well, let me quickly denote those. So this is our x sub 1 and this is our y sub 1. Similarly x sub 2 and y sub 2, and here we have x sub 3 and y sub 3. Alright, so it would be x sub 1, which is negative 2, times y sub 2 minus y sub 3. So that would be 5 minus negative 2. We have to be very careful about the signs. We have to maintain the signs as is. Otherwise, the calculation will become totally wrong. So wherever we have negative coordinates, we need to carry the sign with them, right? So here you see how I have written x sub 1, which is a negative 2, times y sub 2 minus y sub 3. So y sub 2 is actually positive 5 minus y sub 3 is actually negative 2. So I have noted it like that, plus x sub 2. What is x sub 2? Well, that is positive 3, times it would be y sub 3 minus y sub 1. So y sub 3 would be a negative 2, and minus y sub 1, that's a positive 3. So we can write it like this. and then plus we have x sub 3, so x sub 3 is actually positive 3 times it would be y sub 1 minus y sub 2. So what is y sub 1? Well, that's a positive 3, and minus what is y sub 2? That's a positive 5. So we can write it like this, and now let's simplify this. So this is actually half times, so this is negative 2 times 5 plus 2, 7. So negative 2 times 7, that is negative 14. And then we have negative 2 and negative 3, that is negative 5 times 3. So that would be negative 15. And then we have 3 times 3 minus 5, that's negative 2. So 3 times negative 2, that's negative 6. So let me say negative 6 right here. Instead of a plus sign, I'm just using the minus sign. So this is negative 6 right there. So from here, we see that this is half times negative 14 and negative 15, that's negative 29, and negative 6, that's negative 35. We have the area like this, and that is equal to negative 17.5, and that would be square unit. Of course, whatever is the unit, that would be square unit. Now if we ever get an area with negative sign, we have to take the absolute value of it. So actually the area in this case is 17.5 square unit. So we are going to take the absolute value. If we end up with a negative value, we have to take the magnitude of it. So here the area is actually equal to 17.5 square unit. And if we ever get a positive value, then obviously that should be fine. We don't have to do anything extra. But if we ever end up with a negative value like this, we have to take the magnitude of it. I hope everything made sense. Thank you for watching. See you in the next video.